So in this problem, we need to determine the equation of a circle that passes through the origin and intersects the positive side of the x-axis and the y-axis to form chords having a length of 4 and 6 units respectively. Now let's try to understand the problem graphically. So we have the Cartesian plane with the x and the y-axis, and this is the circle that's passing through the origin. Also, it is intersecting the x-axis with an intercept of 4 units. So that means the coordinate of this particular point, let's call it A, will be 4, 0. And it intersects the y-axis. That means it's going to have a y-intercept of 6 units. So the coordinate of that particular point is going to be, let's call it P, 0, 6. Our goal will be to find out the equation of the circle. It's a very easy problem. So in order to find out the equation of a circle, there are two things that we need. One is the information regarding the coordinate of the center. So let's call the coordinate of the center as C. So that's H, K. And we'll also need the information regarding the radius of the circle. Now, how to find out the radius of the circle? For this, let's do a construction here. We're going to drop a perpendicular from the centers of the circle C to the chord OA. So this is going to be perpendicular. So let's call it D. So CD is going to be perpendicular on the chord OA, and we're going to drop another perpendicular on the y-axis, and we're going to call it CE. So our construction being, we have the construction. So we are drawing CD perpendicular to the chord OA, and we have CE perpendicular to the chord OB. The reason why we're doing this construction, because we know for a fact that whenever we drop a perpendicular from the center of a circle to any of these chord on the circle, that's going to intersect the chord. So that means since CD is perpendicular on OA, that immediately gives us OD is going to be equals to DA. And for CA perpendicular to OB, we're going to get OE equals to EB. Now, we also are provided with the length of the chord. So OA, that has a length of 4 units, and OB has a length of 6 units. So using this fact, we can find out the measure of OD. The OD is simply going to be half of OA. So that means it's going to be 2 units. And the length of OE, so that's going to be half of OB, which is going to be 3 units. Now that we have the measure of OD, so this is 2 units, and OE, this is 3 units. So OE is equals to CD, so that's also 3 units. Now we can easily find out the radius by using the Pythagoras theorem. For this, let's use the triangle. So in triangle ODC, so this is a right angle triangle at D. We can use the Pythagoras theorem. So we have OC squared equals to OD squared plus OE squared, or OE squared is simply CD squared. So OC squared, that's going to be the radius. So we have R squared equals to 2 squared plus 3 squared. So 9 plus 4, that's 13. So R squared comes out to be 13. Now that we have the radius, so our radius will be simply taking the positive square root. That will be square root of 13. Next, we need to find out the coordinate of the center. So coordinate of the center, that's the x coordinate, which is the distance from the y-axis. So this length is 2 units. And the k, which is the y coordinate, or the distance of the center C from the x-axis, that's 3 units. So our center is going to be 2, 3. So now we have the center as well as the radius. So center is 2, 3. So this is equivalent to h, k. So that gives us the value of h. So h comes out to be 2 units and k comes out to be 3 units. And we have our radius equals to square root of 13. So what we'll do, we'll use the standard form to find out the equation. So the standard form of a circle, that means if we have a circle whose center has the coordinate h, k and the radius r, so the standard form is given by the equation x minus h whole squared plus y minus k whole squared. So that's going to be equals to the square of the radius. So let's substitute the value of h, k and r with the respective values that we've obtained just now. So we get x minus 2 whole squared plus y minus 3 whole squared equals to square root of 13 whole squared. And if we expand this, and that's going to give us the general form of the circle. So that becomes x squared plus y squared minus 4x minus 6y equals to 0. So this is going to be the general equation or the general form of the circle, and if we want to keep it in the standard form, so we have x minus 2 whole square plus y minus 2 whole square equals to 13. So this is the equation of the circle which passes through the origin O, and it has an x-intercept and a y-intercept of 4 units and 6 units respectively.